Welcome back to Data Science at Home podcast. I'm Francesco, and in this episode, I would like to continue kind of a conversation about misinformation and agentic AI. In fact, is misinformation in the era of artificial intelligence. Now, misinformation doesn't win because it's loud. That's what many people think. But it wins because it fits how distributed agreement actually works. And there is a model, quite old, from the 90s, in fact, which goes under the name of the naming game. It's a model from complex system science that explains very well the mechanics with very good precision. So hear me out. Now, we keep blaming the algorithm for many of the things that we read online and also that amount of misinformation that we deal with on a daily basis. Platforms, recommendation engines, engagement, maximizing feeds, but the algorithm doesn't really create consensus. Agents do. That at least happens in the real world. Now, the real machinery is older, simpler, and far more robust than any ranking model. It's the same process that decides which word survives in a language and which one dies. Understanding it changes how you read everything you see online. Now, I've spent years building artificial intelligence systems that model agent behavior at my company, Amethix Technologies, and on defense addition problems where the cost of wrong consensus can be and usually is catastrophic. The pattern I keep returning to isn't from natural language processing or reinforcement learning, but it's more from a 1990s model of how populations agree on concepts, or in particular, names for things. So, what the naming game actually is? Well, the naming game, introduced by Luc Stales, a Belgian scientist, is a minimalist model. It works pretty much like this. A population of agents tries to reach agreement on a name for an object. In each interaction, a speaker picks a word from their internal inventory and says it to a hearer, typically neighbors, topology neighbors. If the hearer knows that word, so it means that the hearer has already that word in its inventory, both agents now keep only that word and delete everything else from their inventory. Otherwise, if the hearer doesn't have that word, well, then he has it. So that's the entire model. It's very simple. There is no central authority. There is no truth signal. Very simple rules. But when you look at how the system converges, there is something to reflect. The system converges to a single shared word, not because that word is correct, but because it was the one that happened to survive, in a way, the network's interaction sequence. And so the winner is usually not the best word, it's the word that reached so-called critical mass first. Now, this is not a metaphor. It's the literal mechanism of online consensus. And there are many properties that we have to consider, one of which is the presence of finite memory, why people stop updating. So the basic model assumes agents hold unlimited inventories, okay? You have infinite memory. But if you extend it with finite-sized memories, the dynamics shift quite a bit. So let's have a look. That agents with small memories, or limited memories, can only track a handful of competing claims at once. So when they hit capacity, they simply drop the, let's say, least recently used items, and this means that the first few pieces of information on any topic have some kind of a structural advantage, not because they are more credible, but because they occupy memory before competing claims arrive. So, for example, on X, you see this as narrative anchoring. The initial framing of a story, often wrong or incomplete, colonizes a user's mental inventory before the correction circulates. By the time that accurate information propagates, there is no room for it. And so the memory is full, the slot is taken. You understand the consequences, right? Now, older users on social media don't update their priors more than younger ones because of wisdom, but they update less because the finite memory effect compounds over time. Let's add yet another complication or realistic feature, which is group discussions. Majorities are manufacturing plants. In the pairwise naming game, each interaction is private. So add group dynamics, and again, everything changes. Now, when agents interact in groups rather than pairs, local majorities form faster and exert disproportionate pressure on minority vocabulary holders. A claim doesn't need to be true to win a group discussion. It just needs to be held by slightly more than half the visible participants at the moment the interaction occurs. This is the mechanics behind racial culture on X, pylons on pretty much any platform, and the way a thread of, let's say, 200 replies or more can make a factually broken claim feel like settled consensus. The group interaction collapses the inventory of anyone uncertain. They drop the contested word and adopt the majority word immediately. Mastodons, which is an alternative federated social network. It's a very interesting network, Mastodon. Mastodon's federated structure only partially disrupt this, because group dynamics are scoped to instances. Local majorities form within communities rather than across the entire network. So it's a bit more contained. So you get more persistent minority vocabularies surviving in isolated pockets. This is both the feature and the bug, in a way. Now let's think about communication errors. Introduce a small probability that the word transmitted gets, let's say, corrupted during communication, and the model's behavior changes again fundamentally. So the naming game with learning errors never fully converges. Instead, the population reaches a quasi-stable state where multiple words coexist, drifting slowly. So each transmission carries noise. Misheard claims spread as new claims, and because agents update their inventories based on what they receive, not what was sent, that error compounds. Now, on social media, every layer of sharing is a transmission event with noise, if you think. Quote tweets introduce framing changes, summaries drop qualifiers, screenshots can crop context, sometimes even on purpose. A study claiming, for example, X increases Y by 12% in cohort Z under conditions W becomes X causes Y within 4 hopes, right? So it gets compacted and summarized probably in the wrong way. The drift is not malicious in most cases, it is just structural, you know. There is yet another social network, in fact it's another protocol which is called Noster. There are some details, of course, online everywhere, but even on my newsletter, Defrag Zone, I will paste the link in the show notes of this episode and in the description of the YouTube video. So Noster's model is quite interesting because it encodes the original node with a cryptographic signature and preserves the propagation graph. So in theory, you can trace drift. In practice, most clients don't surface this, and users don't even look. So let's add yet another complication or realistic effect, which is the multi-community networks. Here is where you have echo chambers, which are kind of attractor states from a mathematical perspective. The naming game on networks with community structure produces the most politically relevant dynamics. Within tightly connected communities, consensus forms fast and is stable. Across communities, bridging agents carry words between clusters. The words that cross community boundaries are not the most accurate ones, as one might expect. They are the ones that actually survive translation, meaning the ones that are ambiguous enough to mean something to both sides, or provocative enough to generate a response, right? And this is the selective pressure that inflates emotionally charged context-free claims. They cross networks, nuanced ones don't. The bridging agent on X is the account with followers in multiple communities. What they amplify is not what's true within any one community, it's just what travels across, right? Multi-community dynamics also explains why corrections fail even when they reach the right people. A correction originating in one community arrives in another as a foreign word, not yet integrated into local inventory. The community's established consensus treats such word as noise, and the finite memory effect drops it. You see the mechanism in place there. Let's see what happens when we have multiple words and some kind of a competitive ecosystem. That's a final extension that maps cleanly to the current information environment, which is, as I said, the multi-word variants, where agents hold inventories of entire phrases, framings, or entire narrative structures rather than single tokens. That's, the most realistic change that I made to this initial model. Competing narratives about the same event behave like competing words in this new model. They spread in parallel, accumulate local majorities, interact with errors during transmission, and eventually one framing dominates, not because it was more accurate, but because it was more transmissible in a way in the specific network topology it encountered. The same event can stabilize to entirely different dominant narratives in different network communities. This is not relativism, it's a mathematical property of the system that I'm explaining. Both communities ran the same game, in fact. They started from different initial conditions and different network structures, and they converged to different words or concepts. So what are smart actors doing already? Well, the operational implication is quite weird and strong to accept, but it is what it is. If you understand the naming game, you don't need to lie to win the information environment. You need to seed early target bridging agents and introduce just enough error to prevent convergence on accurate competing claims. And this is not hypothetical. Defense and influence operations have understood distributed consensus mechanics for at least a decade, if not more. The academic literature on naming game variants maps almost exactly onto documented I/O tactics. For platform design, Mastodon's federated structure creates many stable local consensuses with its own instances. That's not worse than X global convergence. It's just different. Noster, in turn, preserves transmission provenance, but doesn't really enforce anything about what users see. So none of these architectures immunize, let's say, against the game. So they reshape which word wins, but that's pretty much it. So what will happen? What should we expect in the next 6 to 12 months? Well, we will see more AI-generated content entering these networks as agents, not just as tools. Synthetic agents, in fact, with designed vocabularies and targeting strategies, will participate in naming games at machine speed. The convergence dynamics, of course, will accelerate, goes on without saying. The error injection will be more and more precise. The meaningful response is not content moderation. Moderation operates on words after they have already propagated. The meaningful response is network-level transparency, which means who interacted with whom in what sequence before consensus formed. Once consensus is formed, that's too late. And that's a structural problem, and right now almost no platform is built to expose it. I want to leave you with a very interesting phrase that I got online, which goes a bit like this. The real misinformation problem is not what's false, it's that the game doesn't check. If you like this episode, of course, come and have a chat on our Discord server. You will find the link in the show notes of this episode on the official website datascienceathome.com and, of course, on the official YouTube channel, link below. Talk to you next time.